Today we're looking about special products of binomials. So we've been learning how to multiply polynomials, and then we learned how to multiply binomials using the FOIL method. And now we're going to look at some special products of binomials, and we're going to recognize some patterns that is going to make it easier for us to be multiplying binomials. So let's go ahead and begin with some practice. I would like you to go ahead and take these 4 problems and multiply the 2 binomials using the FOIL method. So begin with multiplying x plus y times x plus y using the FOIL method. If you did it correctly, you should have gotten x squared plus 2xy plus y squared. If you didn't get it correctly, go ahead and go back to the previous lesson 9.4 and review over how to multiply binomials using the FOIL method. All right, now let's move on to our second problem here, x plus y times x minus y. So go ahead and multiply those 2 binomials together using the FOIL method. And make sure that you combine the like terms in the end. So after you've combined all your like terms, you'll notice that some things cancel out, leaving you just x squared minus y squared. Now let's go on to the next problem, a plus 5 times a minus 5. So go ahead and multiply those 2 binomials using the FOIL method, and then simplify at the end, and you'll get a squared minus 25. Now go ahead and try a minus 5 times a minus 5 using the FOIL method. All right, after simplifying, you should have gotten a squared minus 10a plus 25. All right, last problem. Go ahead and multiply these 2 binomials using the FOIL method. After simplifying, you should have gotten 4x squared minus 9a squared. So recognizing the patterns in special binomials, these just save us time. Now we could multiply them using the FOIL method and get the correct answer. However, if you can recognize the pattern, you're going to save time because you won't have to do all the tedious work of using the FOIL method. And then when we learn about factoring in a future chapter, if you can recognize special products, it will also help you when you have to factor. So it's going to be very important that you learn these special products and be able to identify them when you see them. So the first special product is the square of a sum. So what that means, the square of a sum, is when you have a binomial that is squared. Okay, a binomial like a plus b that's squared. So the formula for this is whatever that first term is, you square it, and then you plus 2 times the first term and the second term, and then plus that second term squared. So this is the formula here. And here it is, a visual representation. So a plus b squared is a plus b times a plus b. So that means that you have a and a, which is a squared. You have a times b, which is ab. You have b and b, which is b squared. And then you have a and b again, which is ab, which is how we get a squared plus 2ab plus b squared. All right, so using this formula, let's go ahead and try a sum of squares and see if we can do it. So this is x plus 2 squared. So notice that the x is the first term, so it's taking the place of the a, and the 2 is the second term, so it's taking the place of the b. So when we write our answer, the first thing we need to do is take that first term and square it. So our first term is x, so we're going to square x, which means we'll get x squared. And then plus 2 times your first term times your second term. So 2 times my first term, which was x, times my second term, which was 2. So I have 2 times x times 2. And then plus Now we take our second term and we square it. So our second term is 2, so we'll do 2 squared. Now it's time to do some simplifying. 2 times x times 2, well, that becomes 4x. And then 2 squared becomes 4. So now we have our simplified answer of x squared plus 4x plus 4. Let's try another one. Let's try 3x plus 4 squared. So notice that 3x is our first term and 4 is our second term. So we start with squaring our first term, so 3x squared, plus 2 times our first term times our second. So our first term is 3x and our second term is 4, plus our second term squared. So our second term is 4, so we'll do 4 squared. Now it's time to simplify. 3x squared, when you do 3x squared, you have to square the 3 and the x. So 3 squared is 9, and then x squared is x squared. And then we'll simplify 2 times 3x times 4. Well, 2 times 3 is 6, and then 6 times 4 is 24. So we have 24x. And then 4 squared is 16. All right, the next special product that we're going to look at is the square of a difference. So here is our formula for the square of a difference. So difference means to subtract. So we're subtracting two terms that form a binomial, and then we're squaring it. So this is the square of a difference. So here you take your first term and you square it, and then you're going to minus 2 times the first term times the second, plus your second term squared. So notice that the square of a difference and the square of a sum are almost identical. The only thing that is different between them is that the square of a sum has a plus right here, and the square of a difference has a minus. So the square of a sum is adding the terms, and then the square of a difference is subtracting those two terms. So that's how you tell the difference between a square of a sum and a square of a difference. So let's do an example. So we have y minus 3 squared. So y is our first term, which is the a, and 3 is our second term, which is the b in the formula, right? So first we do our first term squared, so y squared, minus 2 times our first term times our second term. First term is y, second term is 3, plus our second term squared. So our second term is 3, so we'll do 3 squared. So simplifying, we have minus 2y3, so 2 times 3 is 6, so we have minus 6y. And then 3 squared is 9. Let's do another example. We'll do 2x minus 5y. So we have our first term squared, so 2x squared, minus 2 times our first term times our second term, plus our second term squared. All right, so two binomial expressions, one indicating the sum and then the other indicating the difference, we call those conjugates. So the terms are the same in the binomial expressions. The only thing that's different is that one is adding and one is subtracting. We call those conjugates. So if you're going to multiply conjugates together, this is what it would look like. Here's an example, a plus b times a minus b. So the terms are the same. We have a and b. The only thing that's different is that one is a sum and one's a difference. So if we were to multiply this out using FOIL, we would get this. And then when we simplify, we end up with a squared minus b squared. So this goes to show that a product of conjugates is just the difference of the two squares. Let's look at an example. So here's our formula. We have a product of conjugates, and it's equal to the difference of the squares. So our first term squared minus our second term squared. So our example, we're going to do x minus 4, x plus 4. So this is a product of conjugates. So we take our first term, which is x, and we square it. Then we take our second term, 4, and we square it, and we're doing minus, right? So we're doing our first term squared minus our second term squared. So we end up with x squared minus 16. One more example here. So our first term squared minus our second term squared. And then remember, when you square, you have to square the 3 and the x, so that's why we get 9x squared. And we have to square the 7 and the y, which is how we got 49y squared. All right, so a review of our formulas. The square of a sum is a squared plus 2ab plus b squared. Then we have a square of a difference, which is almost identical, but instead of being a squared plus, we'll have a squared minus 2ab plus b squared. And then we have a product of conjugates, which says that the product of conjugates is a squared minus b squared. All right, so here's another example. And so in this example, we're going to show how knowing these special products can help us do mental math. So for example, if we have 87 plus 93, well, we know that 87 plus 93 is 90 minus 3 times 90 plus 3. And those are conjugates, which means that we can do the product of conjugates, which is a squared minus b squared. So a would be 90 and b would be 3. So 90 squared minus 3 squared, which is 8100 minus 9, which is 8091. So you can see that this was much more easier to do mentally than it was to do 87 times 93, which we would probably have to use pencil or paper or a calculator. Another example is 72 squared. So we know that 72 is 70 plus 2. So we have 70 plus 2 squared, which is a sum of squares, or square of sums. And so we can use this formula, where 70 is our A and 2 is our B. So we have 70 squared plus 2 times 70 times 2 plus 2 squared. And when we simplify that, 70 squared is 490. 2 times 70 times 2 is 280, and then 2 squared is 4. Adding those together, we get 5,184. So again, we were able to do this mentally versus having to do 72 squared by hand or on a calculator. All right, so let's say we have a minus b cubed. So to do this, the first thing you would have to realize is that a minus b cubed is the same as saying a minus b times a minus b squared. A minus b squared is a square of a difference. So to do that, we can use our formula, which is a squared minus 2ab plus b squared. And then we can multiply, we can distribute the a, so a times a squared, a times negative 2ab, a times b squared, and then distribute the negative b. Negative b times a squared, negative b times negative 2ab, negative b times b squared. And then after we simplify that, we end up with our final answer of a cubed minus 3a squared b plus 3ab squared minus b cubed. All right, go ahead and try some problems on your own.